5(3). We're supposed to find the antiderivative of this. So the 36 could come out. And this is t to the third in the denominator. I can bring it up to be t to the negative 3 in the numerator. And then I can use the power rule. So I'm going to have the 36. I'm going to raise this power by 1. So that's going to be t to the negative 2 over negative 2 plus the c. And the negative 2 will make that negative 18. And t to the minus 2, that could go back down as t squared. And that's 21. On this one, the 12 can come out. And I recognize secant x tangent x, the x, as the derivative of secant. And so this becomes now, tangent cosine is not the derivative of anything special, so I'm going to use my trig rules and say tangent is sine of theta over cosine theta times cosine theta. And I can't split this because this is multiplication, but these cosines would cancel, and so then I just got the integral of sine theta d theta, and the derivative of negative cosine theta is sine theta, and then plus the c. This one, I can split this up into 2 because they're subtracting, and so I'm going to have the integral, and I'm going to pull the 4 out of 1 over x dx minus the integral of e to the x dx. And so this is 4. The integral of 1 over x is ln, absolute value of x, and minus the integral of e to the x is e to the x because the derivative of e to the x is e to the x. And then there's a constant. This one, a little bit trickier. When I subtract powers, that comes from multiplying the bases. That would be e to the 3t times e to the negative 4. When you're multiplying, you would add these, and I would get that. Now, multiplication I can't take apart, but that's a constant, so I can pull it out because e is just a number. So this is e to the negative 4. Integral of e to the 3t dt, and the formula in the book says if there's a constant times this, it becomes, we got e to the minus 4, becomes e to the 3t divided by that constant. Now, if I multiply these back together, I get 1/3 for the 1 over 3, and this would be multiplied back together. We'd add these two, and we get e to the 3t minus 4 plus c. Okay, now we're verifying. So if this is the antiderivative, if I take the derivative of it, I should get back to this. See, if I got this, the derivative would be, I can use the power rule. I have a 1/3 out in front. And then on this, I take the 3 down times this to the 2. And these cancel, and I get that. So I verified. I'm supposed to verify here. So I take this, and I take its derivative. And so Excuse me. I think I got something wrong here. 41 is 1/7. Copied the wrong problem. 7. Yeah, because it wasn't working. This one. So if I take the derivative, the 7 comes down. So it'd be times the 1/7. So I'm going to have 1/7 times 7x plus 13 to the 1 less power, which would be 6. And the derivative of the constant is 0. These cancel, and I get x plus 13 to the 6th. Okay. Now they want me to show that this is not correct. That is correct. So if this is the integral of one of these two, then I should be able to take the derivative and see which one of these is correct. So if I have 3x squared sine x, and I take the derivative, then I have to apply, the product rule. The 3 can come out. The derivative of x squared is 2x times sine x plus the derivative of the second, which is the sine of x. Derivative of sine of x is cosine x times the first, which is x squared, and I pulled the 3 out. And I can multiply back in, and you can see that this is going to be 6x sine x plus 3 cosine of x times x squared. So 6x sine x plus 6 cosine x. I'm not getting 6 cosine x. Let's see. The derivative of the first. Let's do this one again. Derivative of the first, which should be, I'll leave it together here. The derivative of that would be 6x times sine x plus the derivative of the second, which is negative cosine x times the first, 3x squared. There we go. Which is, oh, not that or that. Which one? So I must have copied something wrong from the book. It's neither of the ones I wrote down. 6x sine x plus 6 cosine x. That the antiderivative 3. Well, that doesn't work out. Neither one of those are the antiderivative of that. So g of x is not the antiderivative. This is not the antiderivative of that, nor of that. When I take the derivative of this, I get this, which is neither one of those two. They messed up here. So that problem's messed up. I won't do that one again. All right. It says dy dt is this. So to find out why, I have to integrate this. And this is t to the 1/2. And so to integrate that, it would be, increase this by 1. So that'd be t to the 3/2 over 3/2. and so I'm going to put the 2 up there for the 3/2, plus c. However, when I put 1 in, I'm supposed to get 1. When I put 1 in here to the 3/2, that's 1 times 2/3. That's 2/3 if t is 1, plus what would make this come out to be 1, and so c has to be 1/3. So my final answer for y is 2t to the 3/2 over 3 plus 1/3. And on this one, if I integrate, I get e to the x for y plus c. Now if I put 2 in here, I get e squared plus something is supposed to be 0, so c would have to be negative e squared. And so my y then is e to the x minus e to the e squared.